Picture this. A patient walks into your clinic, and there's a distinct yellowish discoloration to their skin, their eyes, or their mucous membranes. Right away, they're presenting you with this absolutely captivating metabolic puzzle. We call it jaundice, right? But it's not just a color change, it's a map. It's a literal distress signal coming from deep within the body's intricate chemical processing system. And our job today in this explainer is to learn exactly how to read that map.
Okay, let's dive into this. Why do some patients turn completely yellow in the first place? Well, the culprit is hyperbilirubinemia. Bilirubin is this yellowish pigment that gets created during the normal, everyday breakdown of your red blood cells. Usually your body processes and eliminates it seamlessly, no big deal. But when something in that internal pipeline goes wrong, the bilirubin literally has nowhere to go. It backs up into the bloodstream and eventually seeps right into the tissues, specifically the skin, the sclera, and the mucous membranes. And that accumulation? That's what causes the visible yellowing we call jaundice.
But here is a truly vital piece of the puzzle. A patient doesn't just instantly turn yellow the moment their bilirubin rises. There's a very specific threshold. That magic number is greater than 3 milligrams per deciliter, or about 51 micromoles per liter. This is the exact tipping point where clinical jaundice actually becomes visible to the naked eye. Until the bilirubin concentration in the blood crosses this precise line, the outward physical signs remain completely hidden from view.
And this brings us to a really fascinating distinction. There's a massive gulf between clinical jaundice, where serum bilirubin exceeds that 3 milligrams per deciliter mark, and latent jaundice, where levels sit dangerously between 1 and 3 milligrams per deciliter. What this essentially means is that a patient can have significantly elevated bilirubin, and their internal metabolic system can be in a state of absolute chaos without them actually appearing yellow yet. Understanding latent jaundice is absolutely critical, because it reminds us that just because there's no yellow tint doesn't mean the liver and blood systems are functioning perfectly.
So to figure out where the backup is actually happening, we really have to understand the normal standard operating procedure. Think of the liver as this massive, highly efficient chemical processing plant. First up, we have bilirubin production. This happens when red blood cells break down, creating unconjugated or indirect bilirubin. Second is hepatic uptake and conjugation, where the liver grabs this raw material and processes it into conjugated or direct bilirubin so it can actually be dissolved in water. And finally, step 3 is excretion via bile flow, where it's shipped out of the liver and ultimately leaves the body. A failure in literally any of these 3 steps triggers our primary diagnostic categories.
So, let's break those down. First up, Pillar 1, pre-hepatic or hemolytic jaundice.
Here, we're looking at what happens before the bilirubin even enters the liver. In hemolytic jaundice, the liver's processing plant is perfectly fine, the machinery working exactly as it should. The problem here is entirely on the supply side. There's an accelerated breakdown of red blood cells, hemolysis, which leads to a massive overproduction of bilirubin. The liver is simply being overwhelmed by this flood of raw, unconjugated material. It's working overtime, but it just can't keep up with the sheer volume of destruction happening out in the bloodstream.
Moving right along to Pillar 2, hepatic or hepatocellular jaundice. So the crucial point is, in this scenario, the supply of raw material is totally normal, but the factory itself is severely damaged. Hepatocellular jaundice happens when there is significant damage to liver function. We're talking about hepatic cell death, necrosis, or severe inflammation, kind of like what you'd see in viral hepatitis. Because the hepatocytes, the actual worker cells of the liver, are dying or damaged, they fail to take up the bilirubin, they fail to conjugate it properly, and they fail to transport it. The entire assembly line just grinds to a halt.
And finally, Pillar 3, post-hepatic or obstructive jaundice. Also known as cholestatic jaundice, this one is basically a logistical nightmare. The red blood cells are breaking down normally. The liver took the raw material and conjugated it perfectly. But the transportation of the processed bilirubin out of the system is defective. Usually this happens because the exit pipeline, the biliary tract, is physically blocked. It could be an extrahepatic obstruction, like a gallstone, a stricture, or even a tumor, like a carcinoma at the head of the pancreas just pressing right on the bile duct. Everything backs up behind that roadblock, spilling conjugated bilirubin directly back into the bloodstream.
Now, what's really interesting about this is how we go about decoding those diagnostic clues.
This synthesis is essentially the ultimate cheat sheet for the medical detective. Notice how the specific shade of yellow changes based on the pathology. A patient with hemolytic jaundice often presents with this pale, almost lemon yellow tint. Hepatocellular damage shifts the tone to more of an orange yellow. But an obstructive issue? That often looks distinctly greenish yellow. And hey, look at the symptom of itching, or pruritus. In hemolytic jaundice, there is absolutely no itching. But in obstructive jaundice, itching is intensely present because the bile salts, unable to escape, are depositing directly into the skin. Bleeding tendencies also give us huge clues. They might show up early in hepatic failure due to a lack of clotting factors, but they typically only happen late in obstructive cases.
And this brilliantly illustrates the two extreme ends of our pipeline. Let's recap. Hemolytic jaundice presents with that lemon yellow skin, no itching, a normal heart rate, but often features splenomegaly, an enlarged spleen, because the spleen is basically the graveyard where all those red blood cells are being destroyed. Now contrast that directly to obstructive jaundice. You've got that greenish yellow hue, the intense itching, late-stage bleeding issues, and interestingly enough, bradycardia, a slower heart rate. That's actually triggered by the high levels of circulating bile salts messing with the heart's electrical system. The systemic symptoms literally give away the exact location of the malfunction.
So by tracing the metabolic journey of bilirubin and carefully observing specific color tints alongside symptoms like itching or bradycardia, we can pinpoint the exact internal failure. Jaundice isn't just a color change, folks. It is a meticulously readable map of human physiology. But it really makes you wonder, if a simple pigment can reveal this much about our internal metabolic pathways, what other systemic secrets are written directly on our patient's skin, just waiting for the right detective to read them?